Okay, so Unit 6 starts us off learning different ways to multiply and divide larger numbers. Now, some of you might be thinking, and I hit this right away, some of you might be thinking, I already know some ways, okay? And I think probably the most common way, and because it's quick and easy once you get to know it, is standard algorithm. Okay, and maybe not for everybody, but for, I would say, a lot of people in this world, which is not a bad thing. It is a good thing. If you know standard algorithm and you feel comfortable and you feel like you can answer questions, multiplication and division, larger numbers using this method, that's awesome. However, I am going to challenge you in this unit to be open to exploring and learning about other methods. Some you have some background with, okay? So the two methods we're going to be focusing on in the beginning of this unit are area models is the first one, okay, and ratio tables. Two things that you should have some familiarity with. We've done a little bit of work with both of these, okay, but we're going to be kind of taking it to the next level. So let's go. So this story problem we're going to be using and then showing it using an area model and showing it using a ratio table. Okay, so Emily was shopping for her summer art class. Each pack contains 17 markers. So I guess she's getting packs of markers. Each pack contains 17. Okay, I think that's important. So 17 markers, and then that's each pack. And Emily bought 13 packs, okay? So 13 of these. Whenever I hear that word of, that kind of is a one word that signals me to multiply or find the product, okay? So multiplying 13 times 17 to figure out how many markers there are. Now, one thing I put here, I want to make, I really want to try to get us in the habit of always making what I call an SE, the smart estimate, okay? So for this problem, we have 13 times 17 or 17 times 13. We can estimate that to be about 10 times 20, which would get you, well, 10 times 2 is 2 with 10 times 2 is 20, with a 0. So about 200. I'm going to put this squiggly equal line, that's the estimate. It's like approximately 200. So this smart estimate is important because when I finally get my answer, it can help me see, like, is it in the right ballpark? Is it reasonable? Okay, so let's go ahead and look at the area model. So for the area model, we're essentially finding, we just did area. Area is length times width. We're really finding the area, okay, the length and the width. So we are using multiplication there. The really only trick here is instead of multiplying numbers that we don't know the basic facts, like 13 and 17, we can go ahead and break, and I put that hint there. These are kind of the hints I put. Break it up. And by break it up, I mean make it easier numbers. Instead of 13, let's distribute it out. Let's make that 10 and 3. So instead of using one number, 13, I just distributed it to be a 10 and a 3. Same thing with 17. I don't know the basic facts of 17, but if I break it up, I know the basic facts of 10 and 7. Now, you can break it up other ways if you wanted to, but I suggest, like, for these double-digit numbers, it's nice and easy if you do the tens digits and then the one digit. The tens place and the ones place, but I can show you in other examples you could break it up differently. Like, for instance, I could do 5 and 5 and 7, no matter what, as long as it adds to 17. Okay, so then instead of finding just 13 times 7, I'm finding smaller items in here, and I kind of line it up. I do 3 times 10, and I like to write it in here. 3 times 10 is 30. Now I'm doing 10 times 10. 10 times 10 is 100. 3 times 7. So I'm going over in here. 3 times 7 is 21. And 10 times 7. And 10 times 7 is 70. So now I have, the product is the total answer, right? It's the length times width. It's the answer is the product. When you have part and part and part and part, these are called partial products. They are just that. They are part of the answer. So we have 100, 30, 70, 21. Okay? All of those are part of the answer. And when I put them all together, all of this will get me that total area, or that total, remember, length times width is area, and in this case, it's the product, it's the answer. So all of these together. So 0 plus 0 plus 0 plus 1, 7 plus 3 is 10, plus 2 more is 12, so 1 up here, 2 down here, and 1 plus 1 is 2. So 221. Okay, so I think there's 221 markers. Now the great thing about using a ratio table also to multiply is that you can go ahead and check your work. Obviously, another way to always check your work is that standard algorithm that we talked about earlier, if you have that hanging out and you feel comfortable with that. Okay, but I want to show you how to use a ratio table as well. So for a ratio table, I really suggest that you label always. Okay, sometimes I forget to label and I just get this whole stream of numbers and I forget what they even mean. Okay, so this is 13 packs and each one is 17. So each one pack is 17 markers. So I like to go ahead and label. And it doesn't even, sometimes it can be like, look, this would be my marker. I can draw a little picture of. Okay, so one pack is 17 markers. Now, I heard somebody say it's the core, using the core 4, and I'm going to show you what that means. So far we did the unit. We did what one pack is. If you double that, that means 2 packs. You just double 17. And you could do your math on the side really quick. 17 plus 17. Or you could do 17 times 2. So you get 34. Now, I can double this. So now I'm doubling the 2. So really I'm multiplying the top by 2 and the bottom by 2, kind of like we do for equivalent fractions. So 2 over 34 is the same thing as 4 over, think about doubling this. So double 30 is 60 and double 4 is 8, so 68. Okay, next up, I'm going to try 10, but this time you're thinking, I can't double 4 and get to 10. You're right. I'm going to go all the way from 1. How do I get from 1 to a 10? I multiply it by 10, and if I do that to the top, I do that to the bottom. So it really does remind me of those equivalent fractions. So 17 times 10 is 170. So I mentioned before that it's the core 4. Ultimately, I want to see how much 13 packs. I want to see how much 13 packs, how many markers that is, right? That's really what I'm solving. It's Emily bought 13 packs. How many markers did she buy? However, if you do this core 4 using the numbers 1, doubling it to get 2, doubling it to get 4, and then going from 1 to 10, so 1, 2, 4, and 10, a lot of times that helps you solve any problem. So for example, I need to get to 13. Well, I already know 10, and I kind of already know 3, because 2 packs plus 1 pack is 3 packs. So I want you to really look here. This can be, it looks tricky. 10 packs is 170 markers. 2 packs is 34 markers. And 1 pack is 17 markers. If I add up that 10 pack, that 2 pack, and that 1 pack together, that would be 13 packs, which is exactly what I need. And let's see how many markers it would be. So 7, 8, 9, 10, 11. 7 plus 3 is 10, 11, 12. And 1 plus 1 is 2. So I get 221. Okay, the last thing I want to mention is writing out an equation. Okay, oh, by the way, my estimate was 200, and in both of these I got 221. So that sounds pretty reasonable. Okay, so the last thing I wanted to mention here is writing out an equation. Okay, and to write an equation, we just need to make sure we have that equal sign. Okay, so 13 times 17 equals 221. So, boys and girls, what we did today was we just took a multiplication problem, and instead of solving it with standard algorithm today, we solved it using an area model and using a ratio table. Okay, so excellent job following along. Just a quick note to students who are in my class, we have gone from Unit 5 to Unit 6, and the way our math notebook was set up, that means that you need to end Unit 5's page number and put up Unit 6. So I ended Unit 5 on page 72, and I started Unit 6 on page 73. If you are not in my math class, you do not have to worry about that. All right? Awesome job following along today, guys.